Today we discuss about the analysis of cubic crystal structure by powder method. Here we discuss the analysis of cubic crystal structure by powder. In earlier lecture we discussed in detail about powder diffraction method and we find how the diffraction angle theta is measured by using the traces which are appeared on the photographic film. That theta is different for the different set of the plates. The result is theta equal to r divided by 2l, that is measured in terms of the radian. We find theta in degree, therefore we multiply by that term multiplied by 180 degree divided by 1. That result we discussed earlier. Here we analyze the cubic crystal structure as we know the diffraction angle theta. Hence, for cubic crystal structure, we write the equation. Hence, firstly we define the Bragg's condition, and from the Bragg's condition, we find the sine square theta. Hence, square on the both sides and simplify. Sine square theta equal to lambda square divided by 4d square. This theta is the diffraction angle or the Bragg's angle that we measure in powder method. Here we measure theta for cubic crystal structure. Hence, we use one of the term for cubic crystal structure. Interplanar spacing d is equal to a divided by root h square plus k square plus l square, where a is the lattice constant and h, k, l are the Miller indices of a given plane in a cubic system. That t term we substitute in this earlier equation and we simplifying again the sine square theta term. Sine square theta equal to lambda square divided by 4a square. Since the d square term, we take the square on both sides. Simplify sine square theta by putting d square, lambda square divided by 4a square. This denominator term is numerator into square root of a square plus k square plus l square. This term we write lambda is the wavelength of X-ray beam used in the powder method. This is monochromatic. Lambda is fixed. A is the lattice constant for cubic system, that is also fixed, and therefore this lambda square divided by 4a square remains constant. Hence, sine square theta directly proportional to h square plus k square plus l square. We directly write sine square theta directly proportional to h square under root h square plus k square plus l square. Now what it shows, that term we get if a and lambda are fixed, means lambda square divided by 4a square is constant, then only we write sine square theta is directly proportional h square plus k square plus l square. From that equation, we say that for simple cubic crystal structure, it gives all possible combinations of HKL, and therefore h square plus k square plus l square is arranged in the increasing order. This is for the simple cubic crystal structure. But for other cubic system like body centered cubic as well as face centered cubic system, some of the diffraction lines are absent and hence all HKL values are not present, or we cannot arrange all combinations of HKL in case of BCC and FCC system. Now, how to calculate the some diffraction lines are absent, means these are not present in such a system. That term was calculated by calculating the structure factor, and if that structure factor is 0 at the specific HKL value, then that HKL is not present in the list of the combination of some HKL planes. Hence, such a planes are absent. If some planes are absent, all are not allowed under BCC and FCC. It gives the extinction rule. Hence, for example, we take one example for BCC crystal structure. 100 reflection is absent, means that plane is absent. All other planes we write in that increasing order. Such an absence gives an extinction rule. Now, why it is absent in BCC crystal structure 100 plane is absent? That will give the explanation here. Because the reflection from the corner atoms in BCC structure and the body centered atoms have same intensity, but they have phase difference of lambda by 2, and then the resulting in zero reflected intensity. Such a systematic absence gives rise an extinction rule. Hence, for BCC and FCC, some planes are missing. That planes missing, if it is missing, then it gives the extinction rule. That extinction rule we determine for the allowed reflections in the cubic system. Which are these extinction rule that we summarize here. For a crystal system, when it is simple cubic, BCC and FCC, we firstly note how we arrange the H square plus K square plus L square in increasing order for all these three cases. Then write here the allowed reflections and which are the absent reflection. Now see here for simple cubic. Here, if the list of all combinations are possible under simple cubic system, means A square plus K square plus A square is arranged in the increasing order, means it must be equal to 1, 2, 3, 4, 5, 6, 7 is absent. That explained in the next slide. 8, 9, 10. Means H is 1, K is 0, L is 0. If we add these three terms by taking the square, we get 1. How we get the 2? If H is 1, K is 1, L is 0. Means 1 square plus 1 square plus 0 square, that is 2. Similarly 3, how we get 1 square plus 1 square plus 1 square, 3. How we get 4, that is 2 square plus 0 square plus 0 square, 4. Similarly 2 square plus 1 square, 0 square, we get 5. 6, 2 square plus 1 square plus 1 square, that we will get 6. 7 is absent since that does not give that increasing order, which does not include in that increasing order. 8, how we get 2 square plus 2 square plus 2 square, then we get here the 2 square 4, 2 square we write again 4, L square 0 square, hence we get 8. 9, how you get? That is 2 square 4, again 2 square 4, 8, 1 square is 2 to 1. Such a allowed reflections for all values of A square plus K square plus L square is possible for simple cubic structure. no any reflection is absent in that case. All combinations are allowed. Means all are arranged in the increasing order. For BCC, we discussed earlier, some of HKL values are missing as we find h square plus k square plus l square in the increasing order. That means if we get the 2, how we get the 2? That is h square is 1 square plus 1 square plus 0 square. 4, that value we get the 2 square plus 2 square 0 square. That will get the 4. 6 we get, how we get? That is 2 square 1 square plus 1 square. 6, 8 means all are even values of h plus k plus l values. Only such a reflections are allowed for BCC. Absent reflections other than even values means odd values of h plus k plus l. These are absent for BCC. For FCC, h square plus k square plus l square is again in the increasing order, but some combinations are absent, that are 1, 2, 5, 6, 9, 10. These are missing. Under that FCC, allowed reflections include when H, K and L are all odd. For example, H, K, L are all odd means H is 1, K is 1, L is 1. Such a reflection is allowed. The sum of these three we get 3. Or all are even. All are even means we write it 2, 0, 0. This 2, 1, 0 is not allowed. Since there is one of the term is even and other is odd. That is not allowed. Whether it is all odd or all even. Same as 8. How you get 8? It should be all odd or all even. 8 we get 2 square, that is 4. 2 square 8, L square 0. Hence we write 8, and that is the allowed reflection for FCC. Which are not allowed? Not all odd or not all evens. That are the absent reflection. Such a simple cubic BCC, FCC we compare, and using that which are the allowed reflections, which are absent in the various combinations of HKL, then we decide a given crystal structure is whether it is a simple cubic or body centered cubic or face centered cubic crystal structure. For example, we write another slide. See here, these are the Miller indices of the deflating plane for BCC and FCC. These are the all increasing order. Right here the cubic planes HKL 1, 0, 0 means if we take the square we get 1, 1, 1, 0, get 2, 1, 1, 1, 3. In the same way 1, 2, 3, 4, 5, 6 all are for simple cubic. All planes are allowed. No any missing here. Means 1, 0, 0, 1, 1, 0, 1, 1, 1, 2, 0, 0, 2, 1, 0, 2, 1, 1 and so on. All are allowed for simple cubic structure. But for other system, BCC and FCC, we discussed earlier, some are missing and some are allowed. Now, which are the missing? For BCC, all even values of H plus K plus L values. All even values of H plus K plus L means if we add H plus K plus L and if it is the result is even, then that reflection is possible 1, 1, 0. But for FCC it is not allowed, since when HKL are all odd Here all are not odd or not even. Therefore, that plane is not allowed under FCC. See the another example. 111. This is allowed for simple cubic, but for BCC it is not allowed. Why it is not allowed? Since H plus K plus L should be even. Here we get H plus K plus L is odd. Therefore, BCC is not allowed. But for FCC, that plane is allowed. Why it is allowed? Since when H, K, L are all odd or all even. Here all are odd. Therefore, FCC that plane is allowed. Another case 200. That plane is allowed for simple cubic, BCC as well as FCC. Now why BCC it is allowed? Since H plus K plus L is even. 4 is even. Therefore that plane is allowed for BCC. But for FCC this is not allowed. This is also allowed since when HKL are all even or odd. Here all are even. Therefore that plane is allowed. In that way, we firstly calculate now which planes which come under BCC as well as FCC. If all are allowed under simple cubic, then the resulting crystal structure we say that whether it is a simple cubic, BCC or FCC crystal structure. Thank you.